Alright, so this lesson, our objective is to solve exponential equations using logs. So we are going to do a quick review because we have solved exponential equations, we just haven't used logs so far. And as we work through this, I want you to think about when would I solve an exponential equation using a log? So why would I choose to use this method, or what would make me choose to do this method? So we're going to go ahead and we're going to do a quick review of when we have solved exponential equations. So we are going to use the idea, if you remember, when we talked about having a common base to solve these exponential equations. So when I look at number 1, I see I have 5 to the n plus 10 equals 25. So in order to be able to set the exponents equal to each other, they have to have a common base. So I'm going to rewrite 25 with a base of 5. And that gives me 5 to the n plus 10 equals 5 squared. So now that I have a common base, I can just set the exponents equal to each other. And I get n plus 10 equals 2, and then I solve for n, and I get n equals negative 8. Now remember, my variable can be negative, but my log can never be negative. So go ahead and pause the video, and I'd like you to try number 2 as a review. Alright, so hopefully on number 2 you were able to get that a equals 1. If you got that, you can go ahead and move forward. If you didn't, I will explain now. So when I look at 9 and 27, I see that I don't have a common base. So I need to make 9 and 27 have the same base. Well, the base wouldn't be 9 because I can't make 27 be a base of 9. So I'm going to go even smaller and recognize that they both are a base of 3. So 9 would be 3 squared, and 27 is 3 to the third. So I'm going to multiply whatever the exponent is times whatever the exponent of my new base is. So I end up with 2 times the a plus 2 that was up there because I rewrote the base as 3 squared. And then over here I'm going to have 3 times the exponent that was already up there. So then I simply distribute and simplify, and then now that they have the same bases, I set the equations equal to each other, and when I solve them out, I get a equals 1. So what if a common base is not possible? So I'm going to show you a couple ways that we can go about this. There's 2 methods that we're going to use for the sake of this course, and these are the questions that will walk you through either one of them. So can I isolate the exponential expression? Can I take the log of both sides, or do I need to expand the log using the power rule? And then how do I solve and check for extraneous solutions? So let's go ahead and let's look at this first example. So 2 to the x equals 61. So can I isolate the exponential expression? It is already isolated. I have a base and an exponent, and that's it on the left-hand side of the equation. So from here, there's 2 different methods. So I'm going to walk you through both of those. So let's start with this right here is in exponential form. Let's go ahead and put it in log form. So base 2 to the x equals 61 can be written as, so from here, if you notice that my x is isolated, so I have actually solved, this is my true value. But in our calculator, we don't have a log base 2 button. Our log button only does a log base 10. So if you remember back to when we talked about our introduction to logs, we used the change of base formula. So I can rewrite log base 2 of 61 as the log of 61 over the log of 2 equals x. And now that I've done the change of base formula, I can type this into my calculator because we're using that base 10. And so when I do that, I get x equals 5.9307. So that's one way that I can do it, is using the change of base formula. So the other method would be to take the log of both sides. So I'm going to do my work over to the left of this second method. So I'm going to take the log of 2 to the x and the log of 61. And then I want to slowly get to that x. So I'm going to use that power rule because I know that if I'm taking the log of something, I can take the exponent when I am expanding it and I can put it out front and multiply that log by it. And so when I move that x out front, I have x times log of 2 using the power rule equals log of 61. And then to solve for x is being multiplied by the log of 2, so to undo times the log of 2, I'm just going to divide both sides by the log of 2. And so this side will cancel. And if you notice, I'm left with x is equal to the log of 61 over the log of 2, which is the exact same as over here. And that's why the change of base formula works, because I end up with that same number. And so if I were to type this into my calculator, obviously I would end up with x equals 5.9307. So I'm going to let you choose when you solve these exponential equations using logs. You can choose which method you want. So let's go ahead and look at number 4. Go ahead and pause the video and see if you can set up the equation that you're going to use. So either method. Alright, so hopefully you were either able to set up, depending on the method, that you either take the log of both sides or change your exponential form into log form. So from there, see if you can solve the equations using whichever equation you chose. Alright, so hopefully you were able to solve whichever method you chose and ended up with m equals 9.1745. So if you got that, you can go ahead and move on to the next example. If you didn't, I will walk through how I got the steps here. So if you chose this method, once I took the log of both sides, I brought my exponent out in front using the power rule. So that value m minus 7, so that's why I put it in parentheses, because it represents one exponent coming out front, times the log of 8 equals the log of 92, because I took the log of both sides. And then this is being multiplied by this, so if I want to start getting towards the variable, I'm going to divide both sides by the log of 8. And so when I do that, cancels, and I'm left with m minus 7. The log of 92 divided by the log of 8 in my calculator produces a rounded value of 2.1745, and then to get m by itself, I add 7 to both sides. Over here, I went ahead and used the change of base theorem or formula, which says the log of 92 over the log of 8, which gave me 2.1745, and then I added 7 to both sides to get m equals 9.1745. Alright, so looking at example 5, I see that I have 4 times 7 to the n equals 148. So the first question I always ask myself is, can I isolate the exponential expression? So when I look at it, the exponential expression is just the 7 to the n. So I need to get rid of the 4 times, which I know to get rid of times 4, I'm going to divide both sides by 4. And so those 4's will cancel, and I'll be left with 7 to the n equals 37. So from this point, now that we've isolated that expression, I'd like you to pause the video and solve for n using either of the two methods that I've shown you. Alright, so hopefully using, depending on which method you chose, taking the log of both sides or using the change of base formula, you ended up with n equals 1.8556. So if you got that, you can go ahead and move on. If you didn't, I'd like you to look through my work and identify where you went wrong or write down any questions that you might have about my process. And we're going to move on to number 6. So go ahead and pause the video and see if you can isolate the exponential expression and then solve for the variable. Alright, so regardless of which method you chose, you should end up with w equals 0.5 or 1/2. So if you got that, go ahead and fast forward to the reflection part of this lesson. If you didn't, then go ahead and look through my work, see if you can identify where you went wrong and correct it, or make note of any questions you might have. And just like we always do, we're going to go through these 3 reflection questions. In your notes, what are 3 errors you think students tend to make when solving exponential equations using logs? So go ahead and look back through and see any mistakes you make or mistakes you see students could make. What's your summary of this topic so far, as far as your understanding goes, and then rate yourself on a scale of 0 to 3. Go ahead and make sure that you put any questions or points of confusion that you have at any point with any of the problems that we've talked about, and I'll see you in class.